Welcome to my channel Communication Engineering. Today we are going to see energy band and its classification. Introduction. It's about an atom. It is the smallest particle which is made up of three fundamental particles, that is neutron, proton and electron. These are the three fundamental particles. Proton is positively charged. So let us remember like P, proton, positive, P. So P and P. We remember like P and P, proton, positive. So proton is positively charged. Electron. We have proton is positively charged. So obviously electron will be negatively charged. Then we have neutron. Neutron is neutral. Let us remember like neutron N, neutral N. So neutron is neutral. So obviously it is uncharged. So according to Bohr's theorem, he is saying that atom has a planetary type structure. Planetary is nothing but planet-like structure. Why he is saying planetary structure? Proton and we have three particles, right? Proton, neutron. So they are bound together at the center of an atom. So we all know that when some particles or something at the center of an atom or center of something, that obviously we call it as nucleus. We have learned in biology. So same name is mentioned as a nucleus when proton. Electrons revolve around the nucleus in different orbits and shells. Orbits is nothing but repeating path. It repeats, the path will be repeating. So proton and neutron is bound together at the center of an atom, that is nucleus, whereas electrons which revolve around the nucleus. So electrons which is revolve around the nucleus. So first shell will be closely bound to the nucleus, whereas the last shell which is very loosely bounded to the nucleus. So the last shell or last electrons which is called as valence shell or valence electrons. Each shell has its energy level associated with it. So the first shell has a lowest level of energy, whereas the last shell has highest energy level. The energy level of electron in each orbit which is merged into each other to form an energy band. Same way, energy level of valence electrons merge into each other to form a valence band. When valence electrons which absorb the external energy like heat or light, it becomes free from the shell, so it is called free electrons. Why it becomes free electrons? Because the electrons is loosely bounded to the nucleus. I have already said that the last shell has the highest energy level. So the last shell of electrons becomes free from the shell, and it is called free electrons. The energy level of all free electrons and merged into each other to form a conduction band. That is, the electrons free from the shell has an energy level, right? So that free electrons form together and become a conduction band. An energy band which separates conduction band and valence band, that is called forbidden band or forbidden gap. The electrons in valence band are still under the force of attraction of nucleus. So the electrons in the conduction band are free from electrons which is free from the force of attraction of nucleus. No electrons band means there is no electrons exist in the forbidden band. The energy difference between the conduction band and the valence band is called forbidden gap. It is denoted as Eg. Eg represents the amount of energy which is required to given an electron of valence band which is transferred from the conduction band. Whereas Eg, energy gap, is measured in unit, like unit is electron volt eV. Here there is a diagram which shows the energy band diagram, which shows forbidden energy gap, valence band and conduction band. I have said first band is the closest to the nucleus. Second band is middle of the nucleus. Second is middle of the shell, whereas valence band is the last one, so it has highest energy. So when the the electrons which is free from the valence shell or valence electron, that is called conduction band, that is up in the topmost of the energy, that is conduction band. When there is a gap between the valence band and conduction band, which is called as forbidden energy gap, Eg. Classification based on the energy band diagram. Based on the energy band or energy gap, the materials are classified as conductor, insulator and semiconductors. So in semiconductors, it has a very large number of free electrons which exist at the normal room temperature. So there will be no energy gap. So the valence band and conduction band will be overlapped. So there will be no energy band. So obviously the valence and conduction band will be overlapped. For example, copper, aluminium, silver, these are the conductors which conduct electricity. So next is insulator. Insulator which has a very high amount of energy gap, that is about 7 electron volt. Hence it has a very high voltage or temperature. The electron cannot move from the valence band to the conduction band. So as it cannot move from valence band to conduction band, it does not conduct electricity, right? So this is called insulator. Hence these material cannot conduct electricity at all. So it is called insulators. For example, wood, paper and mica are the examples of insulators. Next, semiconductor. At absolute zero temperature, that is 273 degrees Celsius, the conduction band will be empty and it is behave like perfect electron insulators. At normal temperature, some electrons will move from valence to conduction band, hence a few electrons will be available. So the material can conduct partially. So semiconductor is nothing but it conducts electricity partially. That is, it is either it conducts electricity or sometimes it will be insulator. That is, it partially conducts the electricity. So it is called semiconductor. So we have diagram here that insulators which have very large band gap, whereas semiconductors very less, and conductors which is overlap to the valence band. Thanks for watching.